Hello everyone, welcome back to the channel. Today we are going to learn SQL for data analysis. This video will teach you how to think like SQL. This video will change the way you have been thinking about SQL, the way you approach the problems, the way you write queries. All you need to do is just follow along with me. Everything what you need to complete this video will be provided in description box. I will tell you in the video step by step what you need to do, and in next 90 minutes or 120 minutes I will teach you SQL for data analysis in very simple language. You will understand it, and not just understand it, you will never forget it. You will always remember these concepts. You will not have to buy hard things. Just follow along with me for next 90 minutes, and I promise you this can change your life, the way you think about SQL. So let's go. Okay, so before we move on to learn SQL, we will first understand the data that we will be working with today. Because if you understand the data, then only you can do proper data analysis on that data. Okay, so this is a typical orders data. You can imagine that if it is a Amazon orders data or Flipkart e-commerce data, anything, right? Where we have order ID, order date, ship date, customer name, and all these columns as you can see, and we also have sales, profit, and quantity. Okay, the important thing in this data is that you can have multiple rows of data for each order ID. So if you see, if you are placing an order, you can have multiple products, right? So in the same table we have multiple products. You see, this is one product ID, this is one product ID, right? So the data granularity of this table will be order ID and product ID, which means there will not be any duplicate on the combination of order ID and product ID, right? So that is the one thing. Second thing is we have a returns data as well, but we will talk about it later, right? For to start with, we don't need returns data. When we need it, we will talk about it, right? So what I will do now, I will import this data to SQL Server. I have already imported it. If you can see, this table is orders data table. What you need to do, you need to just follow the instruction in the description box. I will put create table, insert table statements, so you can create this data in your database. Now you can use Postgres, you can use SQL Server or MySQL or Oracle, whatever you are comfortable with. The SQL concepts are almost similar, so it will work on everything, right? So my table name is orders data, right? In Excel, if you have to see data, you will just open the Excel, right? But in SQL, you have to say that select star. Star means all the columns, right? These are my columns. So I need all the columns. So that's how I will read the data from the SQL, from the database, right? I will say select star from, and this is my table name, right? In this table I have this one row. This is known as one row, and these are different columns. So I have 1 2 3 4 5 6 7 8 9 10 11 11 columns I have, right? And I have 100 rows in this table, right? Before you start working on it, make sure you use the right database. So I have created this table in master database. So if you go to databases, system databases, we have the master database. So I have chosen this and says new query, right? So it will open in the master database, and then you can just put create table, insert table statements here from the description box, and this table will be then created, and you can just say select star from orders data, right? So this is how you will come to this window, and this is my output, right? Okay, so let's start. So first thing is, if I want to see the data, I will say select star from orders data. It will give me all the data in this table. All I have only 100 rows, so all 100 rows, and all the columns, all columns it is giving, right? Now one important thing is, let's say you are analyzing the data and you are generating a report, right? In that case, you don't need all the columns, right? There are so many columns. There can be 100 columns in a table, right? If you are working with only 3 4 columns, why to select all the columns, right? In that case, you can just say I need order ID, right? I need order date, and I need sales. Let's say I want only these 3 columns. So I can just specify the column names, comma separated, right? and I can just execute it. So I will just select it and say execute, right? So now if you see, it is showing me only the three records, sorry, three columns and all the rows, right? All 100 rows will be visible, only the columns we have restricted, right? If we want to restrict number of rows, right? So let's say I want to restrict number of rows. I don't want to see all the rows, right? Sometimes what happens, you have lot of data, millions of rows, and you just want to see how the data looks like, right? If there are millions of rows, it will take lot of time to load again. So what you can do, you can say top 10. I just want to see top 10 rows from the orders data table. So it will show you top 10 rows only. It will not show you all the rows, right? What you can also do is you can put three columns and say top 10. So it will show you only the three columns or four columns, whatever you want. Let's say profit also I want, right? And in that, I want to see only the top 10 records, right? So it will show you four columns and top 10 records, right? So this is how you have to see the data. If you want to restrict columns, you specify what columns you need, right? If you want to restrict those, you say top 10, right? If I look at this query, right, if I look at this query and look at the order of execution, because we have three keywords here, select, top, from, which will execute first, right? This is important because as we learn more keywords, it becomes very important to understand that which keywords are executing first. Now this is a very common sense thing, right? Just imagine you are a database, okay, you are a SQL, and you are given this query, right? Which keyword you will first execute? Obviously you need to have from first. If you don't know from which table you need data, it you, how you will fetch the columns, how you will select the columns, nothing, you cannot do nothing. So first statement is from, right? Next is select, right? Because I want to select these columns, and in these columns I need top 10 records, right? So your from will go, then select will go, and then top 10 will go, so far, right? Okay, so this is about selecting the data, right? Next thing is, sometimes you want to sort the data, right? So this data is just random, right? However it is stored in database, it is there. So 2020 is there, then 19 data is there, then 18, then again 21. So it is not in any particular order, right? This is in random order. Now you want to generate a report with oldest order date first, and then the latest order date in the last, in the ascending order of order date, right? So what you will do for that, you will use order by clause. I will say order by order date, right? So what will happen? The latest record will be at the last, and the earliest record will be at the top. So if you see 2018, and then in the last we have 2021, right? So this is how you can sort the data. Again you can combine all of these keywords. You can say top 10, and you can select columns and everything else, right? I will show you. But one more important thing is, let's say these are your order dates, right? Now you are saying order by order date, fine. But if you see here, there are multiple rows with the same order date, right? Now what will happen to these? How database will sort it and give the results, right? So it will give me the results in whatever way they are stored in database, because they are all same order date. How database will sort it? No, it doesn't know, right? All are same. If they are different, then it is fine, right? First the earliest will come, next the next one is come. But in this case, if you see, these are all same. So in these cases, if you want to break the tie, right, you can give some other column name as well. So for example, if the order date is same, right, sorted by, let's say, product ID, right? Because these, if you see, are same orders, right? So what I'm saying is, if the order date is same, in that case sorted by the product ID, or sorted by the, let's say, profit. Okay, so what I will do, I will say order by order date profit. Okay, so now if you see, first it will be sorted by order date and then by profit. So if you see, these are the same. So first it is sorted by order date. Now these rows, look at these rows, the order date is same. So now it will go to profit, and the lowest profit will be first. See, 1.9, 5.7, and this has the highest profit, right? So if there is a tie based on order date, it will go to profit. Otherwise, first preference will always be given to order date. Okay, and you can give many columns. Again, there is no limit. You can give 5 columns, 10 columns, anything, right? Now, one important thing here is, if you look at order date and profit, right? They are both sorted in ascending order, right? Ascending means smallest value first, smallest first, then next. What if you want in descending order, right? You want to see the latest order first. So let me comment it profit. So if you want to comment anything in SQL, you can just put double hyphen, right? So now what I'm doing, I'm sorting based on the order date in the descending order. So if you see, the latest order is on the top, so it is reverse now. See, latest is on the top and the oldest is at the bottom, right? So you just have to see DESC. By default it is ascending, but sometimes you will see ASC. ASC means again ascending, but ascending is by default, so you don't have to give it. If you want descending, then specifically you can say I want in descending order. Okay, again, if there is a tie and you want to break the tie, you can again use ascending or descending, right? So if I say ascending, then the order date will be in descending order, and in case of tie, you see the profit is in ascending order, right? So this is the lowest profit, minus 5, minus 1, 2. If I do descending this as well, then order date and profit both will be in descending order. So this row, this complete row will be at the top now, right? Because this has the highest profit on 19/12/2021, right? So if I just see, now the 2.724 is at the top because I am saying profit also descending. Okay, so this is how order by works, and it is very important sometimes, because sometimes the question they can ask, give me the orders, right? Give me the orders which have highest sales, top 5 orders with highest sales, right? Or in this case, I'm saying give me top 5 rows with the highest sales value, right? I need top 5 rows with highest sales value. So what I have to do, I have to do order by sales descending, right? So that I will get the highest sales on the top, right? So these are the highest sales on the top. Now I need top 5 only, so I can say top 5, right? Now again, if you think about it, so if you see 3083 to 1044, we will get. See, 3083 to 1044. Again, you think that you are a database, right? Now, if you see, you have to do order by first and then top, right? Because once you do order by, then only you will know that which top I need to pick. So top is happening after the sorting, not before. If it is before, then we will not get the highest selling rows, highest sales rows from this table. I need highest sales rows. In that case, I need to do a order by sales first and then pick top 5. So if we talk about order of execution now, we will have from, right? From this table. And then which column I want. In this case, select star. Or if you give any other columns, it will select those columns. Then it will order the result by sales, and then it will execute top, right? So this is my order of execution so far. So first I have from, and then I have select, right? It is very logical, right? And then I have order by, and then I have top. So top it as the at the end. In some databases, instead of top, you have limit. So you will say limit 5 instead of top. Okay. Both are same thing. Both work same. Limit also will be executed after order by. And in fact, this is more intuitive, because this is, we are writing after order by, right? Here I am writing along with select. Sometimes confusing, but it's fine. You understand it, right? So in Postgres or in MySQL, you will use limit 5 instead of top 5, but they are absolutely same things. Okay. So this is your top result, and this is how sorting works. Okay. Now let's say I have this data, select star from orders, right? Sometimes you want to create new columns, right? Sorry, it is orders data. This is my data, right? Now sometimes what you want to do, you want to create new columns. So these are existing columns, right? So for example, if I go to Excel, right? So these are my columns. Let's say I want to create one more column. Let's say I want to create um, sales minus, or let's say profit divided by sales. I want to create a ratio which will be profit divided by sales, right? I want to create this ratio. So what I will do, I will say equal to, and I will write that profit divided by sales, right? So it is giving me this ratio, and in this process I have created a new column ratio, right? Now in a similar fashion, if you want to create in SQL, right? So in similar fashion I can just say comma, okay, or I can just say after star I can say comma, and if I have to specify columns I can specify columns, comma, I will say that profit divide by sales. I'll just run this, right? What it will do, it will create a new column. See, profit divided by sales 0.16. Here also we have 0.16.3, right? So you can do any arithmetic operation, you can do plus, you can do minus, or there are a lot of other functions. We will talk about it later. But basically, you want to create a new column, you can create it. Now remember, this is just the in the output you are seeing. You are just creating a report. In orders data table, you still have that many number of columns. We have not added any columns in the orders data. No, just for the reporting purpose, we want to create a new column, right? And these are the result of the ratio, right? Now if you see here, they are proper headers for all the column, but here it is saying no column name. It doesn't look good, right? So what you can do, you can give it a name. So you are saying profit divided by sales as profit ratio, right? And then your report will look nicer. So if you see profit divided by ratio, right? Now, what I will show you, one important thing is I will say order by profit ratio, right? Now, it will work or not. Let's see. Let's see. Because this column is not there in my table, it is only there in my select statement. So, if I run, what will happen? You see, it is working. This proves that my select runs first, because if select is running, then only I am getting profit ratio, and then only I am able to use it in the order by clause, right? So this proves that order by runs after the select, and top is at the end, right? So you can create anything. You can create any number of columns. Let's say I create another where I'm saying sales minus profit as diff, just any random column name I'm putting it, right? So we have one more column in the output, diff profit ratio, and you can create as many number of columns as you want, right? So this is about creating new columns in your select statement. Okay, now let's move on a little bit more. Now, what we will do, we want to filter data. Let's say you are a manager of central region and you are doing all the analysis on central region. You don't need anything else, right? So, if I go back to Excel, right, if I want to filter data, what I will do, I will apply filters and I will say region equal to central. Okay, so this is all my central data, and I can do all my analysis of my data. What is the sales? How much is the return data? Which are the different products I am selling, right? Different kind of things, and you can analyze further. Now, same thing if you want to do in SQL. What you will do? Select star from orders data, right? Now here, where clause will come into picture. To filter data in SQL, we will use where clause. I will say where reason, this is my column name, right? Reason equal to, and in single quotes, you have to give central. Okay. So if I just run this, I will get all the central data. You see? Now, how this happens is, this is very important how where clause works, right? So you have full data this. Now, what SQL will do, it will go to the each row by row. So it will go to the first row and check if region equal to central. No. So it will not give this row in the output. It will go to the second row. It will check is region equal to central. No, it will not give, and it will keep going on until and unless it finds any central, right? So again on this, it will find central, so this row will be there in the output. Again, it will go to the row number 16. Central, yes. So this will be in your output. So it will scan full table. It will go to the each row and give you the result if the where condition is matching. Okay. So this is how you filter data based on a column. Now, another important thing here is if you are filtering on any integer or decimal, right? That time you don't have to give single quotes. So for example, this is my numeric data, sales, quantity, profit, right? So in this that case, you don't have to give in single quotes. Here, if it is a string or if it is a date, we'll talk about date as well, you have to give in single quotes. But let's say you want to filter on data where quantity is greater than 3, right? So you don't have to, or let's say quantity equal to 3, right? So you don't have to give give the single quote. So see, all the quantity 3 it is coming, right? And now when you are working with numbers data, you can use less than, equal to, greater than, anything. So it will give you everything where quantity is greater than 3. You see 5, 7. And just to validate, we can do order by quantity, right? If I do order by quantity, it will show me the lowest quantity here. So lowest quantity is 4, which is greater than 3. You can even say greater than, equal to 3. So it means you will get the 3 as well. See, 3 is also there, 4, 5, 6, everything. 1 and 2 are not there, right? You can even use less than. So again, if I do less than, equal to, it, you will get everything 1, 2, and 3, right? So you can apply all those operations if it is an integer value, right? Now let's come to the date. So we have two columns as order date and ship date. Let's see if we can apply similar kind of filters here, right? So I will say select star from orders data where order date equal to, and again I have to put in single quotes. So I will say 2019. Let's filter on the first record. So I'll say 09 and 70, right? So if I just run this, you see I'm getting all the orders for which the order date is this, right? If I say less than, let's say greater than this, again it is a date, so you can apply greater than, less than, everything, right? So if you see 17/9/2019, all the orders after that, it is coming, right? Let me take this example. So I will say greater than this date, right? And if I just run this, you will see all the orders after this date are there. So if I just do again order by, just to see our results are coming fine. Okay, so if you see, our results are starting from 18/9, which is after 17/9, right? So 18/9 and then so on till the end, right? So now this is how where clause works, and we will see more examples of where clause. But at this point, we want to understand what is the order of execution, right? So at this point, the order of execution will be where clause, right? Why? Because database is smart, and you are smart. You are also a database, right? You want to filter data as soon as possible, right? If you filter data as soon as possible, you will have reduced data to work with, right? The moment you say that I need order date greater than this, only out of 126 rows are there. Now all the other operations, order by, top, or whatever we learn, will be based on only this data set, right? So after from, immediately where clause will be applied. You will get that data, and all the other operations will happen on that. So we will have from, then where, to filter the data as soon as possible. Select the data, what data you need, right, from the table, what columns you need, and then sort the data if you want to sort, right? And then if you want some limited result, give top, right? So this is your order of execution so far, right? Let's move on and discuss few more where clause examples, right? So now, if I go back to Excel, sometimes let's say you are again doing you are a manager of central region, right? So you are saying, give me all the data of central region. Now, on top of it, you want to analyze only the technology data, right? In central region, you want to do analysis on technology data, right? What are the orders and different things. So what you will do, you will apply a filter on region and category, which means there are two filters, and both should be applicable, right? Both should qualify for this order, right? So it should be central as well as technology, right? if we want to achieve this, right, if we want to achieve this in SQL, what we will do is we will say select star from orders data where region equal to central and category equal to technology, right? So if you see, I have two filters now, region equal to central and category equal to technology, which means that the filter and condition means that both the conditions should meet, right? And condition means this condition should meet as well as this condition should meet, right? So let me show you how it will work. Okay, so what it will do, it will go to the each row again, as I said, for where clause, right? It will check region equal to central, no. So it will not even check this, right? Because and means both the conditions should satisfy. If first condition is not satisfying, there is no point of checking second condition, so it will just move on, right? It will not check anything until we reach the central. So let's move on to the central. So now it will say region equal to central, okay, fine, row number 15 is fine, but and there is one more condition, so I need to check is category office supplies, no. So it will not give this row in the output, it will check both the condition to be satisfied to give you a row, right? Let's move on and see where we have central and technology, right? Central and technology here. So here it will come that okay, region is central, perfect, and category is technology, perfect. So it will give this row as well as this row and whatever those qualify this, right? So this is how where clause works. It will check both the conditions if you have and. Okay, perfect. Now we can mix match other data types as well. So for example, here we have reason category. Okay, so let me run this. So we have two conditions. Now what I'm saying, I'm adding one more and conditions. Give me all only the data where quantity is greater than 2, right? Which means these two rows will not come, right? Only these three rows will come because only these three rows qualifying all three conditions, right? If I just run this, you see only three rows are there, 4, 4, 7, and I can add as many conditions as I want, right? I can add a date filter or whatever I want, right? There is no limit how many filter conditions you can put. Just put and just keep putting the filter conditions, right? Now let's talk about little bit more on or. So we have seen the and, right? Now apart from and, we have the or. For example, I can say give me all the data where region is central or category is technology. It means that either one of the conditions should satisfy. Either it should be region or category, right? So if I just run this, you see region is west, but still we are getting this though. See, it will go here, right? It will check. Region is central, no. But it is a all condition. So it will check the second condition as well. Category is technology, yes. Right? When it is all, any one of the condition has to satisfy. In case of and, all the condition has to satisfy. In case of all, any one of the conditions should satisfy. Right? So it is either central or technology, right? So if you see here, this is central, right? So if region is central, will it check the category in this case? No, because this is a all condition. If this condition satisfies, why to check for this? Why to waste time? It will not waste time. It will just go there and check, okay, region is central, give this. So doesn't matter what is category, right? So this is how this end condition and all condition works. Now you can mix them as well. So you can say where region equal to central or category is technology. Anything is fine for me. And within this, give me only the quantity which are greater than 5. Right? The quantity which are greater than 5. So let me do one thing. I'll say order by quantity, just to show you, or just to verify the results, right? So if I just run this, I'm running it without this filter, right? I have commented it, right? So if you see, we have 9. right? 7, 9. So what I will do, I will say greater than 6. So we should get only these rows. So on top of it, whatever is the result of this all condition, on top of it, I am putting one more filter. This is an AND condition, right? So either this condition should, I mean, either one of these two should satisfy. Once they satisfy, in that the quantity should be greater than 5, right? So we will get only those rows. If you see, we have got only those rows, right? So I'll just show you again. I'll just comment it, or let me do greater than 6, right? So I will get very less row. So if I just run this now, so greater than 6 means I'll get 1, 2, 3, 4, 5, 6 rows, right? So if I just run this, you see we are getting only 6 rows, right? So you can mix and match and then or. Okay, great. Now there is a very interesting keyword called between. Okay, so let me run select star from orders, right? Orders data. And now what I will do, what I want all the quantities which are between 3 and 7. Okay, which are between 3 and 7, right? Now there are two ways of solving this problem. One, this I can say where quantity is greater than or equal to 3, right? So if the quantity is greater than or equal to 3, give me, as well as quantity should be less than or equal to 7, or let's say 5. I want everything between 3 and 5, right? So I will go to the first row. I will check if the quantity is greater than or equal to 3. No. Let's move on to the second row. Is this quantity is greater or equal to 3? Yes. And condition, which means it has to check this as well. Is quantity less than or equal to 5? Yes. So it will give me this row, right? Similarly, when it is here, let's say on 4, is it greater than or equal to 3? Yes. And less than or equal to 5? Yes. So both the conditions should be checked on this, right? Now if it is here 2, so is it greater than or equal to 3? No. So it will not give me that, right? Or let's say we have 7, is it greater than or equal to 3? Yes. So this is fine, but it will check this as well. Is quantity less than or equal to 5? No. So it will not give that. So in end we are checking both condition. So in that way we will get only quantity which are between 3 and 5, right? So if I just run this, I am getting all the rows where quantity is either 3 or 4 or 5, right? Now you can write it in another way. So you can say where quantity, so let me just copy this and say quantity between. So there is a clause called between, right? Quantity between 3 and 5, right? So if I just run this, and let's do order by as well, again I am getting the same result, 42 rows, right? It is same thing. It is just instead of putting these two conditions, I am saying quantity should be between 3 and 5, and when you write a between clause, the boundaries are also included. So 3 and 5 are also inclusive, which means 3, 4, 5. If I say between 3 and 6, it means all the rows where quantity is either 3 or 4 or 5 or 6, right? So 3 and 6 are inclusive here, right? So if I just run this, you will see everything between 3 and 6, right? So this is a shorter way. If you have to write a range, then this is a better way of writing it, but otherwise it is absolutely fine even if you are writing like this, right? Now there is one more way of achieving the same thing. So there is a new keyword called in. So I can say where quantity in you give a list of values. So I am saying quantity should be either 3 or 4 or 5 or 6, right? So it will give you all the rows where quantity is either one of them. So this is my in clause where I can give list of values, right? Now this is helpful. Let's say you want all the quantities which are either 3 or 5, right? So you can say 3, 5, right? It is not a range, right? It is not a range, 3 or 5, right? You can, so if I just run this, I'll just show you. See, in clause I am getting only 3 and 5, right? So this is similar to saying all condition. So this is similar to quantity equal to 3 or quantity equal to 5, right? So let me just comment it. This is the same way of saying it. When you say in clause, which means either 3 or 5, right? And this will also give you same 33 rows. So if I just run this, you will see 33 rows. See, same result, right? So in clause is very handy because sometimes you have list of values, right? So for example, you want to see all the sales of Los Angeles and San Francisco. So you will say select star from orders data where city in, right? And now remember, city is a string, so I have to give it in the single quotes, in Los Angeles or San Francisco, right? So I will get data only for these two cities, right? So if you see Los Angeles and San Francisco, only these two cities are there in the output, right? So yeah, this in clause is also very handy, right? You can give it order date as well. So you can say order date in, and you can say give me all the data of 12th as well as let's say 27th, right? So it will give you data only for these two, right? If you see only 12th and 27th, 12th and 27th, right? Also this between clause also can be used with dates. So you can say order date between, right, this and this. Remember, you give in single quotes, right? So also, if I run this, what will happen? Okay, let's run this. So we should get some data ideally, right? So let me run this. I'm not getting anything. So when you're using between, you have to make sure the lower value is first. So we will say, so 2018 comes before 2020, right? So you will say all the data between this and this. If you give higher value first, it doesn't work. So you have to say all the data between 12/6/2020, and let me do order by, just to make sure our results are fine. Order by order date. Okay. So if I just run this, you see we have the latest data of 12/6/2020, right? And the earliest data of 27/8/2018. Right? So this becomes very important. Okay, so this is how your where clause works. Okay, so far what we have seen is we are checking the exact value. Sometimes we want to do a pattern matching, right? So how do we go about it? So now I will introduce a new clause called like operator. Okay, so select star from orders data, right? Now what I want to do, let's say I want to say where, right? I want to know all the customers whose name is starting with A. I'm only interested in those customers whose name is starting with A. So I will say customer name like A%. So what it will do, it will go there and each though it will check if the name is starting with A and then percent. Percent is a wildcard character. It means after A, anything can come. Percent means anything. I don't care. First character should be A, and after that, anything can come. Right? So if I just run this, you see I'm getting only the customer's name starting with A. Right? Now let's say you want to see all the customers whose name is ending with A. Right? So let's see if we have anything. We have no. Let's say N. Okay. Okay, so if you see all these customers, the name is ending with N. So what I'm saying is percentage means anything. Anything can come, right? But after that, in the end, N should be there and nothing after N. You see the single quote is ending. So this should be at the end. We can also say that somewhere in between N should come, right? Or let's say A should come somewhere in between. So in starting, anything can be there or nothing can be there, right? A name starting with A will also qualify. So if I just run this, you see A is there in between, A is there in between. This is also coming, right? A, because it's starting with A, right? Percentage means anything can come or not come, doesn't matter, right? A should be there anywhere in the customer name, right? So this is how percentage works. We have another wildcard character which is underscore. Underscore means there should be exact one character. So let's say I want all the customers whose second character is E. So what I will say, there should be one character, right? Then E should be there, and then anything can come. It means the second character of the customer name should be E, right? So let me run this and show you. So if you see, second character is E, second character is E, second character is E, and so on. Second character is E, 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 right? So this is also very important. Underscore, this is a very commonly asked interview question as well, right? They want to know that if you know how to use percentage and underscore. Underscore means there should be at least, not at least, exact one character. After that there should be E, and then anything can, right? Now let's say question changes to that first the second. So the question again is that second character should be either E or A. Second character should either be E or A. Give me all those customer name. Then we have the third wildcard character, square brackets, and I can pass the values. So what I am saying, there should be one character. Underscore means there should be one character. It is mandatory. And then either A can come and I or E can come. And then percentage, right? So if I just run this, you see Darren is also coming because the second character is now A, right? There should be exact one character. It can be either A or E. Here we are not saying that what character it will be. It can be anything. If I am giving underscore, but there should be one character. Now this is saying there should be one character, but it has to be either A or E. Okay, fine. And percentage means anything, right? If I go a little further, I am saying that first character can be anything, then second should be A or E, and it should end with F. It should end with F, right? So this guy will come, this guy will not come, right? Or let's say end with N, right? So let me run this. So we have 43 rows, and now we have only 11 rows, right? So these guys have second character is either A or E. There's this E, Kane, right? And then ending with N, right? So this is how you will use these different kinds of wildcard characters. They are very handy sometimes and very useful during your interviews as well. Great. So this is your where clause. Where clause you will use day in day out in your job, in your interviews. It is one of the most important keyword in SQL. Okay, so make sure you understand it. Make sure how it works. It goes to each row, right? Because we will see some filters, advanced filter in this session later, that we have to filter on group of rows, right? But where filter works on row by row. Make sure it is you understand it right way, that it will go to the each row and give you the result. Okay, great, fine. Let's move on. Now what I want to do, this is all fine, but when I'm doing some analysis, right, when I'm doing some analysis, I want to aggregate data, right? I want to aggregate data and see some results. So for example, I want to see what is my total sales. So far I'm just seeing in the table, right, orders data, right? So if you see, I'm saying this is my sales. But what if I want to see the total sales? What is the total sales that I have done? Right? So in Excel, if you have to do the same thing, let me remove the filters. Right? If in Excel you have to do the same thing. So there are many ways. So one way is you can just say equal to sum of sales and you use the full column. Right? So if I just select this. Okay, so this is my total sales 21504.5317. I'm just doing sum and selected all the values of sales column, right? Now, if the same thing I have to do in SQL, also it is very similar. So we will say, give me select sum of sales. This is what I am doing in Excel as well, right? Give me sum of sales from orders data, right? Here I have to specify the table name as well. So if I run this, I am getting 21504.5317, exactly the same. Again, if you see, there is no column name. So I can say as total sales. So this is also known as column aliasing, and this is how you will get the proper header name, right? Also you can just give space, that also works. So if you give sum of sales space total sales, this also will work. This is also a way of aliasing it, but generally as is a good practice, it looks clean, right? If you just give space, sometimes it is confusing, right? So always give as, right? You can just say sum of sales and you will get overall sales that you have done total, right? Now this is sum of sales. You can also do minimum, and what is the minimum sales in my table, right? So it will give you 1.248, right? If you want to see maximum, it will give you max, right? So it will go to the each row and check where is the maximum sales, which is the maximum sales, right? So it is your maximum sales is 3083. Let's prove this. So I'll just select star from orders and do order by sales, right? So we can run multiple statements together, so I'm just running these two together. If you see, this is my orders data, right? First query. And if you see sales, I have done a order by sales. So lowest sales will come on top, 0.4444, and the highest will at the bottom, right? So if you see, highest sales is, if we go little more further, highest sales should be 22638, right? Okay, this is my orders data. My bad. Okay, so if I just run this, and if we look at the sales, see maximum sales is 3083.43, and this is also my maximum. If I do minimum, then I should get this one, 1.248, right? So if I do minimum, I will get 1.248. 1.248, this is my minimum and minimum, right? So this is how you can use any aggregate functions. We even have average, right? So if I do average, it will give me average sales. What is average sales? Average sales means total sales divided by number of records, right? Now let's say I don't have this average function. How I will do? So I can get sum of sales simply, right? But I need number of records. So to get number of records, I have the count star function. Select star from orders data, right? I want to know how many rows are there, right? Sometimes there are many rows, right? Or after filter, I want to know how many rows are there, so I can say count star. So it will give me number of records, so it will give me 100, right? Again, I can alias it, number of records, right? Okay, now coming back to average sales, one way of, this is the right way, but just to understand it, I will say select sum of sales, right, divide by count star, right, as average sales, right? This is also my average sales. Okay, we are just seeing if it is all fine or not, right? So I say sum of sales divided by count star as average sales from orders data. Okay, so let me run this. If you see, the result is exactly the same, right? Result is exactly the same. So count star means number of records. This is total sales divided by number of record is my average sales, right? So this is how this average works. Okay, great. Now, so far we have seen five functions, right? Sum, average, min, max, count, right? In all of the functions except count, I have to give the column name, right? I want sum of what? I want sum of sales or sum of profit, whatever I want, right? Or I can even put two columns. So I can say give me average sales and average of profit. This also works perfectly fine. So I will get two columns as average profit. Okay, but one thing common what I'm trying to say is that I have to say that this profit or sales are columns. So in all the functions, aggregate function, we have to give the column names except count. In count, it is not mandatory, but it makes a difference that I will tell you, right? So if I do a count star, it just give me number of rows, right? It doesn't need a column. Why it needs column? You want to know number of records in your table, you will say count star and it will give you. But you can also, what you can do, you can say count and column name, let's say order id. Now in this case, it will give you 100 again. It doesn't make difference. So let me do this. Count star and count order ID. So in this our data, it is not making any difference. But there is a concept of null, right? So let me introduce some null data. So select star from orders, right? What I will do, I will just put two of the rows as null, right? So let me run an update statement. So update statement is not part of this analysis, but if you understand it, it is great. What I am doing is I am just putting as null. Null means we don't know, nothing, right? So I'll say update orders data, right? Set, let's say ship mode equal to null, right? Where where sorry, orders data it is, my bad. Okay, where order id in, and let's put null for two orders at least. So let me pick this order 83. Okay, and let me put so there are two rows, both will be set to null, and let's put this, right? Or let's put something here on the top, this one. Okay. Okay, so what it will do, it will set ship mode to null for orders data, right? Ship mode is not there, my bad. This is ship mode is not there, so let's put city. Okay, so this is fine. Okay, for those affected, let's look at the orders data now. Okay, so if you see for these two, null means nothing. I don't have data. In your CSV, it is empty. In your Excel file, it is empty. In SQL, it is represented at null. And if you see, it is background is orange, right? So this is how you will set null values. But this is not in our scope. Let's leave it for now. But for now, let's understand that we have data as null, right? Now, before I go to the count, back to count, if I just want to see what all records are null, right? So you can say where city equal to null, right? But this will not work. Let me run this. Okay. So null means unknown. Null cannot be compared to anything else, right? So we have a special reserved keyword is null. So this will give me all the data where city is null, right? Similar to is null, we have is not null, right? So it will give me all the data where city is not null, right? Now this not keyword is also very interesting, right? When we talk about where clause, right, where we said that quantity equal to 3, we could have also said quantity not equal to 3, right? So it will not give 3, everything else. Similarly, when we said in clause, so we have not in clause, so I can say quantity not in, right, 3 comma 5. Select star from orders data where quantity not in 3 comma 5. So it will give me everything except 3 and 5. See, 2, 4, 5, everything is coming 1, right? So this not clause is also very handy. In for checking null also we have is not null, right? So it will give me everything where city is not null. Okay, now coming to the count again, right? So in the count, let's run it on the count of order ID, and then let's say count of city, right? Let's see what will happen. So now if you see, we are getting 100, 100 and 96. So when you give a column name in count, it will not count null rows. It will ignore the null values and give you the not null count of city column, right? So order ID, there is no null, so it is absolutely fine. But in count, we have 100, count star is 100, order ID is also 100, but city is 96. Okay, great. Now, last variation is you will all sometimes see that people will do this count one. Right? Instead of a star, they will say one. One also means same, right? One also means same. One is just that you are counting one as the number of rows, right? So it will also give you 100. So count star and count one are same. It doesn't matter, you can give count of 100, right? So it is counting number of hundreds as many number of times as many rows are there, that's it, right? You can say 500, it doesn't matter. It is just a constant value, right? So it is always giving you 100. So count is star and count of any constant value is always same. You can say Ankit, right? This also works fine. So all are fine, 100, right? But the only thing is when you give column name. One more thing is you can even give distinct, right? So there is a keyword called distinct. Let's talk about it. So let's say you are in Excel, right? Let me remove the filter. There is no filter. So let me add a filter. Okay. Now in this filter, you want to see what all categories are there in your data. So you will go drop down. Okay. You will see furniture is there, office supplies is there, technology is there, right? But in SQL, we don't know how to do it, right? If I just run this, I will see all the data, right? With our naked eyes, we cannot see, right? That how many are there. It can be more or less. Manually, I have to check. So for that, we have a keyword called distinct keyword, right? So I will say, give me distinct category from orders data, right? So this will give you whatever is the distinct values, right? Not all, distinct unique values. So furniture, office supplies, technology. Okay, so this again distinct keyword is very handy when you are analyzing the data. You can even say category and let's say reason, right? So what it will do, it will give you the combination of all the distinct combination of category and reason. So if you see furniture central, furniture east, and so on, right? Now this distinct keywords can be used in the count as well. So I can say count of distinct category, right? Or count of distinct city, right? So it will give me the distinct values. So if you see here, see last one is distinct city. So there are 32 distinct city. Distinct categories. There are three distinct categories, right? You can always give alias as distinct category, right? For each column you can give a alias, but you can also use distinct along with count. Okay, so this is my distinct keyword and this is my aggregate functions: count, average, say sum, max, minimum, right? Now these count, max, min, so far we are doing on overall data, right? We are doing on overall data, which means what if I want to analyze all the data but I want to summarize it, right? This is one of the most use case in your data analysis journey. You want to summarize it. Basically you want to see how much sales I have done in category furniture, how much sales I have done in office supplies. One thing is you separately write this where technology, sorry, where category equal to technology, right? And you will say sum of sales. If you do this, you will get okay. In technology category, there is total sales, right? Similarly, you will check for furniture, but this is not a good way, right? So you have 32 cities. You won't do it one by one. Not a good way of doing it, right? You want to summarize the data all together, right? For example, in Excel, if you have to do it, right? Let me remove the filter, and I will say insert a pivot table, right? So I will create a pivot table and then I can say, let's say I want for each category. So I will say category and I want to see total sales, right? So I will drag the sales here. It is saying in furniture, this is the total sales. In office supplies, this is the total sales. In technology, this is the total sales, right? This is a great way of analyzing the data instead of checking one by one. Now, similar functionality is there in SQL. You can use group by clause. So, what you will do is you will say instead of where clause, you will say group by category, right? Select category, sum of sales as category sales, right? So you are saying group the data based on category and give me sum of sales. So if I run this, this works exactly same as your pivot table: 11083 5233 5186, right? So this is how you can make use of this group by condition to analyze the data. We can also add more columns. So for example, I want sum of sales. I want sum of profit as well. So I can say comma, give me sum of profit. That's very similar to how we do in the pivot table in Excel, right? So I got category, category sales, and this is my category profit, right? So this you will be using mostly as a data analyst. The group by is your bread and butter. Okay, so make sure you understand it well. So now what we will do, we can do group by on multiple columns, right? So I can say for each category and reason I need the total sales, okay, or total profit. So I will say category, reason, and here also I will take. If I don't take in select, then how I will know, right? So if you see here, it is saying that in central reason, let me do a, okay, it is already sorted. So in central reason, on furniture category, this is my total sales. In central reason, in office supplies, this is my total sales. In central reason technology, this is my total sales. In each reason, I'm getting the total sales category wise. Okay. So again, if I go back to pivot table, I can add reason, right? So if I just go here, add reason, and this is exactly same thing, right? If I just move it little further up, it is in central furniture 1326. If I see here, central furniture 1326, right? So this is exactly how pivot table works in Excel. Okay, so this is how you can aggregate data in SQL. Now here comes the very important thing. Let's look at what if I want to aggregate data and then apply a filter on that. Okay, so let me take a simple example. Let me do by category. Okay, so I'll just remove region for now and remove the region from here, right? And if I just run it, you will see this is my category sales, right, for each category. Or let me take city, it will make more sense. So let me take city, and again here city. Okay, so let's call it city sales. Let's remove it for now, let's keep it simple. So if you see, this is null because there were four records null, so it is coming as null. Now what I want those cities where my total sales is at least 100, right? Where my total sales is at least greater than 100. Now you cannot do here. You cannot say where sales is greater than 100. The where clause will not work. Why? Because where clause will go row by row, right? Where clause, what it will do, or does data, right? It will say that go to the first row, right, and check if the sales is greater than 100 or not. Second row, third row, but it will not tell me overall city wise, right? So where clause cannot be used there. You have to understand it, right? Where clause will go to row by row. It doesn't know what is the sales of all the cities together. I mean, all the, let's say, you have this Los Angeles. It doesn't know what is the total sales of Los Angeles. It only knows at this point that in this record this is the sales, in this record this is the sales, right? So we need to aggregate data first and then apply filter. For that we have having clause. So I will say, so first I will aggregate data, right, and then I will say having sum of sales greater than 100, right? So I'm calculating sum of sales, and then I'm saying that if it is greater than 100, give me those cities. So these are the cities, or these are the null values, right? This is null is also a group, so all the nulls will group together, and this is the total sales of all the nulls, right? And similarly I've got all the cities where sales is greater than 100. I can say greater than 500, and all the cities where sales is greater than 500, right? So all the cities where sales is greater than 500, you can see, right? So if you have to apply a filter based on each row, right, then you will use where clause. And if you want to apply a filter on aggregated value, then you will use having, right? Now we can combine all of this. So I will say, give me all the data. I'm interested only on west region, so I will say where region equal to west, right? So it will filter data of west region, and on top of it, city wise, it will aggregate the data. So let me run this first. So if you see, Only in west region we have only these cities. Okay, in these cities this is the total sales. Within this, give me all the cities where total sales is greater than 500. Right, so these are the cities. Right, so this is how it works. Let's look at the order of execution once again. So let me take the previous one, whatever we discussed last. So we discussed that this is the order of execution, right? Whatever we learned last. So let me take it here, right? Now what else we learned? We learned group by and having. Now where group by and having will come? So just after where immediately group by will take place, because it will group the data first, that on what column you want to group it, right? You want to group it on city, right? So group by will happen, and then immediately having will happen again. It will immediately try to filter the data. So always remember, SQL will try to filter data as soon as possible. So first we have the where clause where it filters the data row by row. Then if you have group by, it will group the data, right? It will group the data, apply the having condition, then select whatever you want to select. You want city and sum of sales, so it will give you. Then you want to do order by, let's do order by. So let's do order by I can say city sales, because after select order by runs, right? Let's say in ascending order. Okay, so my result will be in ascending order. Now you see three rows and in ascending order, right? If you want to run top, so it will, I can say top one, so it will just give me the first row OM, right? So this is the order of execution now. Okay, this is very logical if you understand it, right? Because you have to get the table first, filter the data row wise, then group it, filter on the group data based on the aggregated values, right? Then select whatever you want to select, then sort the data, and then if you want top one or whatever, you can get it. Okay, so this is very important. Great, great. Let's move on little bit more. Now if you see, so far what we have done is we are working with only one table. But in our database, that's not the case. Sometimes we have to work on multiple tables, right? And we have to join them together. So, as I mentioned earlier, select star from orders data. This is my orders data, right? Similar to that, I have a returns data. So, out of these orders, some of the orders were returned, right? So, returns data. Okay. So, let me run these two tables. Okay, so this is my order data and this is my returns data. In return, I have 7 return orders. So these orders were returned. And this is the return reason. Because of what? It is a bad quality, wrong item, or some other reason, whatever it is. So we have all the data. Now I want to do analysis that what is the total sales of return orders, right? Now in this table, I don't know which are the return orders. How I will know what is the sales of return orders? Only in this table I have total all the return orders. So somehow I need to join these two tables, bring those two tables together. Or let's say I want to analyze that because of each return reason, what is the total sales? Because of bad quality, what was the total sales returned? Because of wrong items, what is the total sales return? Because of others, what is the total sales return? I want to do all this analysis, right? Or let's say I want to know in each region how much is the return sales, right? So all this analysis we can do when we combine these two tables, right? Let's say you want to do it in Excel. Okay, so let me delete this. Okay, so you have orders data, returns data. Now you want to do see total sales of return data. So what you will do? You can do a lookup actually. So you can say return. Let's say I want to get the return reason here. Okay, so you will apply a VLOOKUP. So you will say equal to, right, and I will say join these based on order ID. So look order ID, right? VLOOKUP, right? We lookup value. I want to do lookup on order ID, right? Where? So in that I have to give the table array. So this is my table array. So let's select this. Let me select this full. Okay, okay, so this is my full data, comma, right? Now I want to return which index. So here second index 2, and I want to do the exact match. Okay, done. So if I just put it this on the full rows, I'm getting the return reason, right? From here returns data by using the VLOOKUP. Now if I want to do analysis, I can just say here data filter, right? And I can say give me everything else other than NA. So NA means these orders were not returned. So there is no value coming, but these orders were returned. There were 7 orders, distinct orders, because we can have multiple rows for each order, right? So if you should distinct of this, there will be 7 orders, because in the returns data we have only 7 rows. If you see, there are 7 rows, and if we do distinct of this order ID, right, this will be 7 distinct order IDs, right? Let me just show you. Control C, I'll do Control V, and data, remove duplicates. Okay, so if you see, only 7 unique value remain, right? So we have only 7 unique value, right? So let's delete it, delete. Okay, so now you can do all the analysis, right? What is the total sales? You will just say this one. This is the total sales which was returned, right? After putting this filter, right? So this kind of analysis we want to do in SQL. Okay, so in SQL, for this kind of analysis, we have join keyword. We can, based on join, we can join these two tables. So let's do that. So I'll write the syntax first and then explain how it works. So I have orders data. I will say inner join, right? And I'm giving some alias. I'll explain you why. Or let me not give it. I'll just explain how it works. Okay. So I'm saying select a star from orders data, inner join returns data on orders data dot order ID equal to returns data dot order ID. I'm saying join these two tables based on order ID, right? Here also I have to tell that I'm joining based on, I'm doing a lookup of order ID, right? Here also I have to tell that order ID is a column, and based on that join these two tables, right? If I run this now, you will see we have those two columns from the return table. You see order ID and return reason. And we have only the 18 rows. Here also, if you see, there are 18 rows. So if I just see how many rows are there, 19, and one is header. So total 18 rows. Distinct order is 7, but total rows are 18. After I join and remove the NA values. In Excel, you are getting NA values. In SQL, what happens? You will get only the common data. So these order IDs are common in orders data as well as returns data. That's how this inner join works. The order ID which are common between these two data sets will be there in your output, right? So these are the 18 rows. These rows are there in the orders table as well as the returns table, and that's why you are getting only those rows. But now you can do all the analysis in the word. You have the return data here, right? You have the return reason. So if you want to see what is the total sales of because of the returns, so you will say total sales, because you have only the return data. Now after the inner join we have only the data which is the orders which are there in the returns table. So you can say total return sales is 2478. Simple. Now you want to see category wise, right? So category wise you can say category sum of sales, right? It will give you, sorry, I have to put in group by, right? Group by category, right? So if I see, so total in furniture, this is total the return amount. In office supply, this is the total return amount. In technology, this is total the return amount, right? So once you join the data, you can imagine it as a new table with all the columns from both the tables, right? You don't have a new table. It is, again, we are just analyzing data. This is in our output, just we are generating report. In tables they are intact. Orders data table is intact, return data table is impact. We are not changing anything in the table, just we joined it and we can do our analysis. You can imagine after the join you have two tables combined together based on order ID. Now you can do anything. For example, you can say where return reason equal to, so you want to analyze all the data where return reason equal to, let's say, wrong items, right? So now you can filter data on any of the columns, right? So you can say wrong items, right? You can also say and. So this column is coming from return table. Let's say I'm putting one more condition, and city equal to Los Angeles, right? So all the return data where return region is wrong item and city is Los Angeles, right? So now once the tables are combined, this becomes a one table, kind of virtual one table, where you can do anything whatever we have done so far, group by, where clause, top, having, anything we can do, and we have extra columns now to work with, right? So this becomes very, very important. Now what I will do, I want to show you one important thing. So let me remove all of this, and I will say order id equal to, let's say I want to do analysis only on this order id. Okay, I will just run this. You see, it is saying ambiguous column name order id. Now what is happening here is this order id column is present in orders data, returns data table both, right? We are joining on that. So when this column is there from both the tables, the database is confused that you want to take from which table, right? So in that case, I have to tell that I want to take from orders table or returns table, whatever, and then it will work, right? So you have to say table name dot column name, right? If a column is present in both the tables, it will throw error if you don't give the table alias. So you have to give table name dot column name, right? Now here this comes the important point. So in our inner join, this is how the syntax is, right? This is my table. We call it left table because it is left to inner join, and this is my right table, right? And then on, and then I'm saying join orders data order id with returns data order id. So this is how you give the join condition, right? Now, the general practice is we give alias. So, similar to the alias we give to columns, we give it to tables as well. So, I can say from orders data O, or I can say as O. But general practice is for table we just say O, right? And for returns data, I am giving an alias as R. Now, everywhere I can refer to those tables as O or R. Instead of writing full name, I can just say O or R. So I will say O dot order ID equal to R dot order ID. This way, your query looks clean. Sometimes this table names is big, right? So you don't want to give those big tables name everywhere, wherever you are referring to the columns. So you can just give alias O, R, and then use it everywhere. So again, I can say O dot order ID, right? Now, if I run this works absolutely fine, right? Now this is fine actually. If you say any other column, so for example if I say order date, right? Order date or return reason, there is no problem as such, right? Because these columns are unique, right? These are not present in both the tables, right? Order date, okay, right? But the best practice is, if you are joining multiple tables, if you are using a join, always give alias, because let's say this query is there, right? Now this is already there in production and you are coming and seeing it. Now looking at the query, you cannot tell that order date is coming from which table and return reason is coming from which table, right? Column names can be anything. So what you have to do, you have to open this table, do select a star and see if it is present. Open this table and see if return reason is there. And we can join multiple tables. We can have 5 tables joined, 10 tables joined. So it is always a good practice to give the alias, even if the column name is not ambiguous, not in there in both the tables. You will say O dot and you will say R dot, right? This query looks very clean. It is very clear that orders data is O, returns data is R. I want order date which is coming from orders table. I want return reason which is coming from return table, and order date is coming from orders table, right? And this is how you should write your queries. Okay, make sense? Great. This alias is very important. You, even if you don't give, it is working as we see, but it is not a good practice. It will really not help you. Okay, great. Now next question come into my mind. Okay, before that, let's look at the also order of execution once again. Right now, if you see in where clause, I can give filter condition on any columns. It can come from orders data or it can come from returns data. It means The join is happening before where. So joins, right? So from immediately it will do join whatever table we have to join with, then where, group by, having, select, order by top. Right? This is how it works. Now you will say, I want to do like Excel. So for example, in Excel, I have all the data, right? For non-matching data, I have NA, right? And for all the matching data, I have the return reason, which is a great thing. Now I can analyze all the data together, right? With error join, the problem is I am seeing only the returns data. What if I want to see all the data? Give me NA. Wherever it is not there, give me NA, right? And that's when left join come into picture. What left join will do, right? Let me do star again. It will give you all the rows from left table. When I say left join, the left table is this because it is from to the left of this keyword, right? And this is my right table. What left join means is give me all the data from left table and matching data from right table. So if you see all 100 rows are there, and wherever there is a return data, it is populating, right? Wherever it is there, it is populating, and wherever it is not there, it is null, right? Null means nothing. It is not available, it is not present, right? So for this order it was not returned, it is not present in return table, so the order id and return reason is null. And left join is very, that's why it becomes very powerful and it is very popular as well, right? Now I can do further more, I can answer more question. So for example, if I say give me all the data which was not returned, right? I need all the orders which were not returned. Try yourself, right? Without doing left join, how you will do it, right? See, with orders data, you have all the data. If you join with returns table, right? Inner join, you will get only the returns order. Now with the left join, you are getting all the data. What I am saying, give me all the data which is not returned, right? This we cannot do it, right? So what we will do, we will do a left join first, right? So we have all the data now, and we know that wherever it is not returned, the order id or return reason from return table will be null, right? That's what I want, the orders which are not returned. So I will say where r dot return reason is null, right? It will give me all the data, all the orders which were never returned. So if you see, we are getting 82 rows, 18 rows were for return data, and this is all the data, all the orders which were never returned. So this is why left join is very powerful. We can go one step further and do more analysis, right? Now on top of it, I can do again group by or filtering or anything, right? Now one important thing when you join the tables is you can use alias as this o dot star. It means give me all the columns from orders table. So if I just run this, you see I'm getting all the columns only from, see, join is happening, everything is happening. Even if I do inner join, that is happening. It is just that in the select, I'm selecting whatever columns are needed. So O dot star, right? Where R dot return reason is null. So yeah, I have done inner join. So R dot return reason will not be null, right? That's why we are not getting anything. So if I run this, it is an inner join, right? I'm only getting those records where there is a return data, right? So comma, I will say R dot star, which means it will give me all the data from return table as well. So if I just run this, because I am doing an inner join, right? All the data will be populated because I am getting data only for return orders. So if I say return reason is null, I will not get anything, right? Why I will get? No, obviously, right? So if I say is not null, then I will get everything, right? So this is how it works. So coming to this, I can say O dot star comma R dot star. So it will give me all the columns from orders table first and then from returns table, right? I can give in any order. So I can say R dot star and then O dot star. So which means it will give me columns from return table first. See, order ID, return reason, and then this is orders table data, right? I can even specify a particular column. So I can say give me all the columns from orders data and from Return table give me return reason. I don't need order ID. Order ID is already there from orders table, right? I just need return reason. So these are the unique columns now. There is no repetition of order ID now, and this is how you can select whatever columns you want to select. Okay, you want just the order ID and return reason. You want to just find which are the order IDs which were returned. So you can just say o dot order ID comma r dot return reason. So we will get only those two columns. Okay, so you can mix and match. Order of columns also doesn't matter. In table, you can have order ID first and then reason, but in the output in your report, you can take reason first and then order ID. So it depends on you how you want to generate the report. Okay, great. So this is how inner join and left join works, right? So let me change it to left join and let me do some more magic. So for now, I will say O dot star and return reason. Now what I want to do, I want to see total sales for each return reason. So because of others, what was the total sales? Because of bad quality, what is the return sales? Because of wrong item. So I will say group by return reason, right? And remember, always give the alias, right? Okay, and in select I can select only the return reason now and say sum of o dot sales as return sales, right? Now what will happen, because I am doing a left join, there will be a record with null values, right? So I can say that because of bad quality this much. Okay, so we have two different return reasons, wrong item and wrong items. So we will fix this further, right? But for now, for wrong items and wrong items, this is the sales. For others, this is the sales. For bad quality, this is the sales. And for return reason, null means these orders were not returned, right? So non-return items, this much is sales, and for different return reasons, this is the sales, right? So once we do left join, it opens many door to do more analysis on our data sets. Okay, great. So this is my group by and joins, right? There are two more joins, right join and full auto join. But for the simplicity, we will not discuss them. I'll tag some videos where you can understand them, right? But for now, let's move on and understand few more things. Okay, the most important are inner join and left join only. You will be using them most of the time, 99% of the time. So just focus on this for now, and in the another video I'll just tag it and you can watch it later. Okay, great. Now let's understand one more thing, right? We are seeing here that there is some problem, that some places it is wrong item and some places it is wrong items, but they are the same thing. But for some reason in our data pipeline there is some mistake, right? And we want to fix it. Okay, one way is we tell the data engineer that guy, update this value, this is wrong. But let's say you don't have time and in your code, SQL code only, you want to fix it for now to generate your report. Okay, so what we will do so let's work with the returns table. Select star from orders returns, right? I will create new column, right? So if you see bad quality is fine, wrong items has a problem. We have a wrong item somewhere, right? Instead of wrong items, we have wrong item. Where is it? Wrong items, everything seems to be wrong items. Let's do distinct value, distinct return reason, right? Here it is fine. So why we were getting wrong here? Let's see. Wrong item and wrong items. But here we don't see it, right? Returns data. Oh, sorry. This is returns data. My bad. Not this. Okay. So let's see this. Yeah. So this there is something wrong. So let's look at the data. Okay, so if you see, we have wrong item and wrong items, right? So what I want to do, I want to fix this. So we have a case when statement, very powerful statement. So I will say case when, it is like a if else condition, right? I will say case when return reason equal to wrong item, right? then make it as wrong items, else give return reason at itself. Okay, I'll just explain the syntax, but it will just fix my problem, right? And as new return reason. Okay, so let me just run this. So if you see now, if you see, this has become wrong item. This is wrong items now. So case when you can give multiple conditions here, right? Case when return reason is wrong item, then I'm saying make it wrong items, right? Otherwise, take return reason as it is end. So it is starting as case and ending at end, and then I'm giving a column alias, right? Now I can use this column instead of the other column, right? Let me show you another example of case when, right? So let's say select star from orders data, right? What I want to do, I want to create a new bucket, right, based on the profit. So what I want to do, I want to create a new bucket and say when profit is less than 0, right, then I want to say that this is a loss, right? When profit is greater than 0 but less than 50, then I want to say it is a low profit sales, right? And if it is less than greater than 50 and less than 100, I will say high profit. And if it is greater than 100, then I want to say very high profit. So these kind of bucket I want to create, right? Very important thing again. So what I will do, I'll write a case one statement. Okay, so just bear with me. I will say case, right? It will end here as profit bucket, right? And here I will say case when profit is less than 0, then it is a loss. Okay, when profit less than 50, then low profit, right? Sorry, low profit. Sorry, my bad. In single quotes I have to give low profit, right? So I'm giving multiple condition. Then again, when it is less than 100, then high profit. Else I can give else is optional, but anything which is greater than or equal to 100, if it is not falling in any of the bucket, will go to else, and I will say high profit. Okay, and as profit bucket, and let me run this. So if you see a new column is created, it is less than 50, low profit, right? It is negative, which means it is loss, right? If you see, this is high profit because it is greater than 100, right? So this is how this case when statement we can use to check multiple condition and drive a new column based on that. Okay. Now there is one very important thing with case when statement. In case when statement, the order of execution is from top to bottom. So it will go to the top, it will check the first condition, right? If it doesn't qualify, if it qualifies, then it will assign loss. If it doesn't qualify, then next it will go to this, right? Which means if I do this, so oh sorry, my bad. So I will say less than 50, or let me do one thing. I will just move it little up. Okay. So high profit, I am doing this. So what I am saying, if it is less than 0, then loss. Then profit less than 100, then high profit. Then less than 50 is low profit. Now just guess what will happen. The problem is low profit ones will also go into high profit. Because anything less than 50 will be less than 100 as well, right? So anything less than 50 will immediately go here. Right? So if I just run this, there will be no row of low profit. You see, there is no low profit, only high profit, loss, or very high profit. Right? Got it? So the problem here is, if you see, if it is less than 50, right? If it is less than 50, sorry, it has to be very high profit. My bad. Okay, so we have this very high profit. Okay, 219, very high profit. Okay, now if you look at this, what is happening is, if it is less than 0 is loss, which is fine. Now when it is less than 100, so 41 is also going here. You see, 41 is also going in high profit, right? Again, if you see 6.8, 6.8 also going here, right? Because it is top to bottom. So you need to make sure when you are putting case one statement, there is no contradiction, right? So you will put this first so that it works perfectly. Okay. Now there will not be any problem. Now it is fine. Okay. Great. Let's move on. Now what I'm going to do is, I will do one thing. I will just, instead of this greater than less than condition, I can put full condition so that even if I mess up with the order, it should work fine. So I will say profit less than 0, then loss. And then I will say when profit between 0 and 49, then low profit, right? So this between is including of 0 and 49, right? Then I'm saying low profit, right? And then I will say profit between 50 and 99, then high profit, right? Else very high. Now this is more conservative, right? Even if I change the order, it will work fine. So even if I put here, right, it will be fine. Why? Because if it is less than 50, it will not go in this, because this has to be between 50 and 99. So I will have proper low profit and high profit now. See, low profit is there. Why? Because 6.8 will not satisfy this condition. So whatever we discussed that we put in where clause can be put in when condition. I can put and, right, and let's say reason equal to whatever, right, and I can put it, and based on that condition the when will be executed and see if it goes in that bucket or not, right? So this is how your case when works. Very very important for data fixing, right? As we say that the transition has some issues, so we fixed it, right? So all those data fixation or making groups or making buckets can be done using case when statement. Very important and very intuitive as well. Okay, great. Let's move on. Now what we will do, we will learn some functions, date and string functions. Okay, so let's start with string functions. So let's start. So I will say select, let me take some space and say select star from orders data. Okay, so this is your orders data. Now what I want to do, I want to check the length of, what is the length of the customer name, how many characters are there. So what, for that we have a length function. As you know, we can create a new column just by putting comma, right? I can put comma, I can be in same line or next line, doesn't matter. I can have comma here as well, doesn't matter. I want length of customer name. So we have the length function. This is a string function and it requires only one argument, as cust length, right? So if I just run this, it will give me a new column where we have number of characters in customer name. So if you see, this is 6, 7, 8, 9, 10, 11. So 11 characters, 15, 14, right? So this is how this works. Now there is another functions called left. So if you want, let's say, four characters of customer name, right? Or let's say from order ID. If you see in the order ID, the first two characters is kind of country name, CA, maybe Canada, and US, maybe United States or whatever. Right? So I can just say from order ID, give me first two characters. Right? So left requires two argument. First the column name and second how many characters you need. Right? So we will just execute this. You see, I am getting CACAUS, right? So this left function can be used to extract left characters 2, 3, 4, whatever. Similar to left, we have right, right? Let me name it as right value, whatever, doesn't matter, right? So it will give me the right two characters. Or let's say I want write 1 2 3 4 5 6 characters, right? So I will get the ID properly. So I will get order ID 6, right? So it is giving me from the right 6 characters, 1 2 3 4 5 6. So I have the 6 characters, right? So this is how you can use right and left functions. We have more functions, like for example, we have a very interesting functions called substring. So I will say substring, right? Now substring takes 3 arguments. So let me explain you. What I want middle characters, which is the year, if you see, right? So what I want from the third characters, I want 4 characters, right? That's what I want. So this is the third character, CA-2. So this is the third, not third, sorry, fourth character. 1 2 3 4. What I'm saying, from order ID, from the fourth character, I want 4 characters, right? It is not from this to this. It is not like I want 4 to 8. No. From 4 character, I want 4 characters. This is how substring function work as year order. Whatever it is, we don't know, right? So if I just run this, you see, we are getting 2020. This is how it works, right? Let's say if I want 2 characters only. So from the fourth character is 2. It will give me only the 2 characters, right? So if I just run this, you see 20, 20, 20, I'm getting everywhere 20, right? Let's find the last 2 characters of this year. So I will say 1, 2, 3, 4, 5, 6. From 6 character, give me 2 characters. From the sixth character, give me 2 characters, right? So this is how it will give you 2 characters, right? So this is very handy. Okay, let's talk about another function called replace function. In replace, what you can do, you can replace a value in a string with some other value, right? So for example, let's say I'm saying in customer name, right? Replace C with P for whatever reason. I want to replace C with P. So let's see what will happen. So if you see, wherever C is there, so if you see clear glute, it is player glute, right? C is replaced with P, right? As wherever you see C, anywhere in the string. So if you see, let's see somewhere in between C, this. Here we have C, right? It is replaced with P, right? So you can replace it. It is not just single character. You can give a string. So you will say replace CL with PA. Okay, just random examples I am taking, right? So instead of CL, we have PA, right? Wherever CL is there together as a word or not as a word, just consecutively anywhere, it will be converted to PA, right? So you can use this replace function, again very handy. You can use it a lot. Okay. Now there are more functions. You can read about it on the SQL Server website or anywhere. There are so many documentation and there are so many functions that you can go through it. I'm not going through all of them because it doesn't make sense. It will take a lot of time. So you can just go and see different kind of functions. But if you understood them, you can understand other functions as well. Right? Let's move on to the date functions because date functions are very, very important. Date functions. Okay, so let's start. So I'll say select star from orders, right? Okay, so this is my orders data again. Orders data, my bad again. Sorry for that. Okay, so now what I will do, what I want to do is, I want to know the year-wise sales, right? In 2020, how many sales I did? In 2019, how many sales I did? Now you will say that do a left. So you will say do this left of order date, right? And get me the 4 characters. So it will give me the year and sum of sales, right? Group by. Now these functions you can use anywhere. So I can say group by left of order sales, right? So if I just run this, I got it. And in 2018, this is the sales. 2019, this much is the sales, and so on. But this is not a great way, right? Because the problem is in larger data sets, these functions may take time. when your column is a date column, right, we have the spatial functions, right? Not just, let's say you want quarter wise. Now, how will you do? Quarter wise, you won't be able to do using left or something because quarter is not there anywhere, right? So we have some spatial functions, right? Using that, we can derive year, month, week, quarter, whatever from these date because these are dates, right? So database has all the information about these dates, right? So let's understand how these functions work. Okay, so I will say order ID. Let's take whatever columns are required. Order ID, order date, and then I have a date part function. What I'm saying is from the date, give me the year from the order date, right? As order year, right? I can use this in the group by as well. So you see, I'm getting the year, right? So this is the 2020 in order date 2020. It is 2019 2019. I can even get month. If I just say month, right, it will give me month, right? This is the 11th November 6, right? I can get quarter, right? So quarter I can get, and then I can aggregate and say in each quarter what is the total sales, right? First quarter, so there will be two value. Quarter one is Jan to March, and then April, May, June is second quarter, and so on, right? So you have all the information. If you say week, it will give me the week, which week it is, right? And then again you aggregate data and say so starting from January first week, it will go till 52 week of each year, right? So you can aggregate data based on week, right? So for example, let's go back to month. I want to see month wise what is the total sales, all the months together. So months of 2000 sorry, January 2020, January 2019, all together in January, how much sales I have done. So I'll just say this, right? And then group by this. I don't have to give alias here, remember, right? This is just a group by, right? And then I will say sum of sales, right? And I will just comment this for now. So I got this, that in January total sales is 201, in March this, and so on, right? And now let's say I want year as well, year plus month. So I will say, let me just copy this comma, it is actually my order month. So let me take month, and this is my order year. This is fine. So I'll just take year, right? And I have to take this as well in group by, right? Otherwise it will throw error because I want year and month both, and then I want to aggregate data of sales, right? So if I just run this, you see in 2019 January, this is the total sales. In 2020 January, this is the total sales. In 2020 March, this is the total sales, right? So all of this analysis of all the date properties, be it quarter, year, month, you can do using this date part function, right? Again, in the documentation, I will share the link of the documentation where you can see what all things you can extract from date, right? You can get weekday if it is a Tuesday or whatever, right? Similar to date part, you had a date name function as well, right? Before we go there, in SQL Server, you can get this using year function as well. So you can just say year of order date. This also works, right? If you are working on MySQL, you have to use like this only. So you will say year of order date, right? And you can say month of order date, right? And this also works as order month. So you can directly use these as well. This also works, right? So it is absolutely fine. Uh, okay. Now there is a date name function as well. So let me just take it back. Select order ID, order date from orders data, right? And instead of this, I will say date name, week, and let's say month of order date, right? So instead of the integer, it will give me the names as well. So for reporting, again, this is good. This is November, this is June, this is October. Instead of numbers, you are getting the names actually, right? And you can say order month name, whatever, right? You can get again week name as well, Monday, Tuesday, Wednesday, Thursday, all of that. Using date name, you just have to give week. So you can again explore yourself, right? So this is my date part function or date name function. Let's move on to the next function, which is date diff function. So here I will introduce ship date, right? So what I will do, let me just create new query. Okay, so I will say date order ship date, order date comma ship date, right? Let me remove this. So now I have order date and ship date, right? Which is fine because let's say you placed order on 8th and then it was shipped on 11th, right? Now you want to see, you want to analyze that how much time it is taking from order to ship date. You want to find number of days between order date and ship date, and that's when date diff function comes into picture. You will say date diff. Now you want date difference in what? Number of days, number of months, number of years. So for example, here you could give anything, year, month. Here also you can give. So I want number of difference in days. Between what? So your first date, the earliest date, order date, and then ship date. Right? As lead days, whatever. Right? So if I just run this, you will see that I will get 3 days. Right? 11 minus 8 is 3. If you see, if even if they are in different months, right, then also it works fine. So we can see some examples. So but it works. So if you see, this is 27 August, this is 1st September, and there are 5 days between these two dates, right? So this will help you in getting number of days. You can even say number of month, right? So if they are in same month, it will be 0, right? But if they are in different months, then you will get 1. So all of this is 0, but here if you see, they are in different month, so it is 1. It is not that number of days between these two is 30, then it will give 1. No. If they are in different months, so this is in August, this is in September, so it will give me 1. Right? If they are in same month, then it will give me 0. Right? If you want that kind of functionality, then you have to find number of days between these two and then divide it by 30. Then you can do it. Right? But here, month will give you if they are in same month or not. Right? Again, if I say year, if they're in same year, then it will be 0. If they're in different year, then it will be 1. So if you see, most of them, all of them are 0 only. We have all the orders where order date and ship date are in same year, right? But if they would have been in different years, let's say order date on 31st December and ship on 1st of January, so it will give that there is a difference of 1 year. They are in different years. Again, you can do quarter. So all those parameters that you can pass in date part, you can pass in date diff as well. Okay, and again you can do a group by and get all of the information. Okay, the last function we will talk about on date is date add function. Okay, date add function again very handy. So for example, if you want to add some days, so I will say in order date. Okay, again you want to add days, how many? 5 days in order date, right? And I will say is as order 5, right? If I just run this, you see, we have 8 and I added 5 days. If you see, I have hard coded. So it is 13 now. Right? 12 plus 5, 17. Right? So you can add days, you can add month. If you just change it to month or let's say year, it will add 5 years to my order date. Right? If you see 2020, it is 2025. 2019, 2024. Right? If I want to go back 5 years, I can just say minus 5. Right? So if I just run this, you see minus 5 from 2020 to 2015, right? So you can use all those combination. What you also can do, you can use another column instead of hard coding. So for now I'm using quantity column because that's a integer column, and let's say you have another column where we have number of days it will take to reach, right? So you want to check what will be the delivery date, right? And how many days it will take. Let's say you have in another column, let's say quantity column, right? Or let's say from ship date 2 more days will take to deliver, and I want to see what is the delivery date, right? Let's say this is a lead days column. For now it is quantity in our table, but let's say I want to add this number of days in ship date. So I will say date add, right? How much quantity, right? in what ship date. So this will be my delivery date, right? And this is my day, right? These many number of days I want to add, right? So if I just run this, you see, if this is 2, so 11, ship date is 11 plus 2 is 13, right? 16 plus 2 is 18. 18 plus 5 is 23, right? So you can make use of date add function to add days or subtract days from a date. Again, you can add days, year, month. All of this is common in all of this date part, date name, date diff, date add functions, right? So these functions are very handy, very useful, and you will be using them day in, day night when you are working on actual data. Okay, so very important functions along with case when. Case when is also very important because many times you will be using case when you learn advanced SQL, right? I'm not going to cover advanced things in this tutorial like subqueries, CT, window functions, but their case when is very important, right? So I hope this was useful this session. I hope you understood the SQL, how it works, how it runs in the backend, what is the order of execution, right? So order of execution is important, right? We have covered everything whatever, so we learned these concept only, right? When you talk about all these functions, sum function, or let's say EL function or date add, string functions will run along with select, right? Because those are all the things in select, so those will run along with select. In select, whatever columns you choose using functions will be there, and then order by and top. So this is the order of execution. Remember this will help you when you learn more advanced concepts as well. Thanks for watching. Do share this video and like this video. It takes a lot of effort to create so long video. Thanks for watching till so far. Have a good day.